Number 4. If A is a subset of B, if and only if A intersection B is equal to A. So we have to prove this using the proof by equivalence. So we all know that a biconditional statement is composed of two conditional statements, which is P implies Q and Q implies P. So here in our statement, P implies Q is if A is a subset of B, then A intersection B is equal to A, and our Q implies P is if A intersection B is equal to A, then A subset of B. So for P implies Q, if A is a subset of B, then A intersection B is equal to A. So now we have to suppose that A subset of B. We can now show that A intersection B is equal to A. To show that A intersection B is equal to A also need to prove that A intersection B subset A and A subset A intersection B. So for A intersection B subset A, so we let X be any element of the intersection of A and B. Hence, X is a proper set of A and X is an element of B. So in particular, X is a proper set of A, so A intersection B subset B for A subset A intersection B. So since A is subset of B and X is an element of A, so X is an element of B. So X is an element of the intersection A and B. So hence, A is a subset of the intersection A and B. Thus, the intersection of A and B is equal to A. So therefore, the statement if A subset B, then A intersection B is equal to A is true. So for now, suppose that the intersection A and B is equal to A, then show that A subset B. So for Q implies P, if A intersection B is equal to A, then show that A is subset of B. So let X be any element of A. So since the intersection of A and B is equal to A, X is an element of A. So we have X is an element of the intersection A and B. So thus we have X is an element of B. So A is a subset of B. In particular, X is an element of B. So A is a subset of B. So in conclusion, therefore, the statement if A intersection B is equal to A, then A is subset of B is true. Then the statement if A is subset of B, if and only if the intersection of A and B is equal to A, is proven to be true using proof by equivalence.